Environmental factors. The composition of food material affect the resistance of microorganisms in organic salt and increase or decrease their heat resistance. Fat, protein, and proteinous substances provide some production of the cell and spores, thus increase their heat resistance. Sugar likewise increase the heat tolerance for the microorganism, especially of the yeast and mold. The variability of the microorganism is influenced by the pH of food. For most spore forming bacteria, maximum heat resistance occurs near natural pH. Hence, bacterial spores are more easily occur near natural pH and destroy in the food product at the pH 3 than in the meat or vegetable products at in the pH 5 or above. This has been established that all food with the pH value of below 4.5 can be heat processed at 100 degrees centigrade. Otherwise, the chicken, meat, fish, and vegetable whose pH exceeds 4.5 must be heat processed at 100 degrees centigrade or higher. One reason of limiting temperature of to 100 degrees centigrade for heat processing or acid and high acid food is in the acid in the food retard the growth of the non-acidic bacteria and their spores that maybe survive heat treatment at the temperature. Secondly, even if the spores are not destroyed, these will not be harmed and they cannot be germinate in such products. Moreover, microorganisms do not usually thrive in heavy sugar syrup that are commonly used in the canning of the fruit. On the other hand, low and medium acid food like meat and vegetables are contaminated with heat resistance from animal body, intestine, soil, etc. Therefore, higher temperature are needed to process them. The particle proposal in heat processing the food processor regards pH 4.5 as the delivering line between the food that can be heat processed at either 100 degrees centigrade above. Time and temperature relationship. The distribution of microorganisms depend on a part upon the length of time they are exposed to the particular temperature. Yeast and mold are easily destroyed at 100 degrees centigrade or slightly lower. The bacteria are their spores required higher temperature. The destruction affect the heat rapidly increase as temperature increases. Hence, the heat processing at 121 degrees centigrade is much quicker than the 100 degrees centigrade. For instance, in low acid media, Clostridium bacterium spores are destroyed at 100 degrees centigrade in 330 minutes, while at 115.5 degrees centigrade may require only 10, and at the 121 degrees centigrade just 2.79 minutes. It is less harmful for the food or the exposed to high temperature for the short time than to the low temperature for the long time. The time required to kill the microorganism at the given lethal temperature is known as the thermal death time. The relationship between the number of the survival and the time of the explore at the length temperature very similar for all organisms. All has enabled preparation of the thermal death curves of target microorganism. Thus, mathematically speaking, logarithm of the number of the survivor in a straight line function of time and its horizontal displacement varies. The different organisms or diverse food are considerable.